Hi class. For the rest of chapter 6 we're going to be looking more into just different types of quadrilaterals. In the next couple sections specifically we're going to be looking at parallelograms. What you need to know about a parallelogram is it is a type of quadrilateral, so it will only have 4 sides, and it's a quadrilateral where both pairs of opposite sides are going to be parallel to each other. So I'll write opposite sides parallel. And the way that you see that marked on the picture is you will see that with arrows, and these are parallel because they both have one little arrow, and these two are parallel also because those have 2 arrows. So that's a parallelogram, and once you know something is a parallelogram, there's actually 5 different properties that always happen, and you probably are kind of already familiar with some of these, so I will write the property out and then do marks on the picture for each one. So if this is a parallelogram, the first thing that you know is that the opposite sides are congruent, and it is different markings. If you have the arrows, that's saying that they're parallel. If you have like the same number of little dashes, that's saying that they're congruent. So just a quick example of this, if this side is 8, and then this side here would be 8 also. Or, you know, you might have them in terms of x and you have to set them equal to each other, but you know those opposite sides are congruent. The next one is another one that it just kind of looks like what it is. The opposite angles are also congruent. And that's only true when you know it's a parallelogram. Okay, so these 2 angles would be congruent to each other, and also those 2 angles. And actually something else that you can do, let's just say this is like 120 degrees. Well, you know this one's 120 degrees also. So if you wanted to find those other angles, a couple ways that you could do that. We learned in the last lesson that all 4 of these angles are going to add up to be 360. So you could figure it out that way by adding these 2 up and subtracting that then. I put a plus sign. Subtracting that, you get 120, and then you can divide that into the 2 equal parts. Otherwise, the other way is because you know that these are parallel, you have some consecutive interior angles, and that's actually the next thing that we're going to do. We're going to say that the consecutive angles are going to be supplementary. And you don't have to call these consecutive interior angles because there's only interior angles for these. You know, with the parallel lines you might have exterior angles as well. But let's just say like these angles here and these 2 are going to be the same because they're opposite, and you have that. So really any pair, like these 2, or you could even have them like this way, these consecutive angles, or you know, any of the other ways, you know that those 2 angles are going to add up to equal 180 degrees because they're supplementary. So a couple different ways you could figure that out. Like in this one, these would both be 60, and you have the 120 and the 60 that are going to add up to equal 180 degrees. So for this next one is a specific type. This next one says if this is a quadrilateral and you have 1 right angle, so if you have a quadrilateral where you have 1 right angle and this is a parallelogram, then you know that the opposite angles have to be congruent, and you also know that the consecutive angles have to be supplementary. So if this is a parallelogram and you have 1 right angle, then what you actually have is you have 4 right angles. Or this would be a rectangle, just as an example. And then the last thing, we don't actually find this last thing until we draw in the diagonals. So I'm going to draw in these couple of diagonals here, and I'm going to draw both of them in. And if you have the diagonals in a parallelogram, then what you know is you know that the diagonals bisect each other. And I'm going to do some markings on here, but I'm also going to put some letters for some vertices. So let's say we have A, B, C, and we'll call this one D and E. Well, I know that these two are going to be congruent, so I know that AB is congruent to BC, and then I would also know that those two are congruent. So that would be BE is congruent to BD. You don't necessarily know that those diagonals are the same length, and if I actually go up and kind of just add in a different parallelogram and make it a little more like extreme, with like those angles being like more obtuse and more acute, you might be able to see it a little better than this picture here. But if I draw in those diagonals now, hopefully you can tell that this diagonal is much longer than that one, but that doesn't change the fact that those two lengths are the same and these two lengths are the same. Another way you could say the same thing is you could say that like B is the midpoint of both of the diagonals. I usually just say the diagonals bisect each other. Okay, so looking at this example here, it says a wall-mounted mirror uses parallelograms that change shape as the arm is extended. I actually have one of these in my bathroom. I'll have to show you a video of that as they extend. Here we are in my bathroom. This is the mirror my husband uses to cut his hair, but I just kind of wanted to show you how this works as you move this arm in and out. If I move this arm out all the way, these angles all become right angles, so this looks more like a square or a rectangle. If I move this in, you can see that these two angles are acute, but they're still congruent, and those obtuse angles are still congruent also. If I move that in even more, the opposite angles are still congruent, and that's the property of that parallelogram. And it's going to be like that no matter how the arm moves. And it says that within this parallelogram, it says angle J is 47 degrees. So just knowing one of those angles, that actually allows you to figure out all the other ones. So you can find angle L would also be 47 because those are opposite angles and those are congruent. To find these other ones, M and K, those would be the same also, but these two are going to be supplementary. So you could find angle M just by doing 180 minus 47 degrees, and that gets you 133. It says now that suppose this arm is extended further to where J is 90 degrees. So I'll just erase that quick. If J is now 90 degrees, it says what would be the measure of all the other angles, and you could just say that they would all be 90 degrees also. And then to justify, you could just say, you know, it's that fourth reason we just talked about, or you could write down like if one angle is 90, then all the angles are 90. Or you could even write, you know, because then it would be a rectangle. It could be a square. I guess you just wouldn't really know what those sides are, if it would be a square or a rectangle. A rectangle is just kind of the more general word for it. Okay, so then doing some examples here, I want to find these variables. There's different ways that you can do some of them. I'm going to start by finding where X is in the picture. So X is here, and that's representing the length of QT. Well, QT is going to be the same as RS, so I could just set 5x equal to 27 and solve that. So X is 5.4 for that side, and the reason would be because those opposite sides are congruent. When I'm solving for Y, I see Y here, and I also see Y here. And if you remember that those diagonals bisect each other, we would know that point P is the midpoint. So to solve for y, you could set 2y minus 5 equal to y plus 4. And as I solve this, I'll just tell you, sometimes it's kind of hard to tell if it's talking about the angles or the sides. One way I can tell is that these don't have degrees next to them, so I know that it's talking about like those segments instead of those angles. You should get y to equal 9. And then this last thing, I want to find angle, or I want to find z, and z is here for this angle. And to find that angle, I actually don't have the whole thing like we did before, but I do know that these lines are parallel, and because those are parallel, I have some alternate interior angles here. I would know that those alternate interior angles are going to be congruent. So I can set 3z equal to 33, so z equals 11, and that would be my answer for that one. For this one here, solving for x, I'm going to locate where I have x in the picture, and these are consecutive angles. So they're not going to be equal to each other, but I am going to be able to add them up and set that equal to 180 degrees. So I can solve this for x by adding 6 and then dividing by 6. So let's see, 6x equals 186, and when you divide by 6, you should get x to equal 31. When I look for where y is in the picture, I notice I have these two sides, and those are opposite sides, so this one here I can set them equal. So I have 4y equal to 8, or y equals 2. And then for this last one, what I'm going to do for that is pointing to these parts of the diagonal, and I know that this is the midpoint, or that those diagonals bisect each other. So I can set 3z minus 4 equal to z plus 5. So I will solve that. So I get 2z equal to 9, or z equals 4.5, or 4.5. For this last one, the directions say determine the coordinates of the intersection of the diagonals. Well, what we need to remember is that the diagonals will intersect at the midpoint. For those two diagonals. So I'm going to take a minute to graph this. If you just want to pause it and graph it on your own and then hop back. I'm just noticing this too. This is going to -8, so just kind of, I think this only goes to 7, just go over a little bit more. So go ahead and pause this for a second, graph it, and then come back. Okay, so there we go. We have this graphed. I think it's easier, instead of just doing the calculation for the midpoint, to actually get this on graph paper so you can see. And you will probably want either a ruler or something so that you can make sure that you're getting these lined up well, or use like the side of your notebook or something. I want to find where this midpoint or where this intersection is. So I can kind of tell where it is. It's a little hard to tell exactly what that coordinate is. It looks like maybe like -1, 2.5, but because it's part way, I'd rather do some double checking. So what I can do is I can really just take like either of these two that are opposite from each other, and I can calculate the midpoint. So when I calculate the midpoint, I'm going to be adding -6 and 4 and dividing by 2. So when I do that, I get -1. And I'm going to be adding the 7 and the -2 to get 5 and dividing that by 2. So that is at 2.5. So this would be my coordinate for the intersection of those two diagonals, because it's at the midpoint of each of those diagonals. I hope this helps, and we'll be working on this in class.